Alright, so today we are going to talk about a method of solving systems using matrices called Gauss Elimination. Now, to talk about Gauss Elimination, we need to first define what an augmented matrix is. An augmented matrix is simply taking the coefficients and constants of a system of linear equations and writing them in standard form of a matrix. So, for example, this is not an example we're working out. This is just more of a pictorial example of a system and an augmented matrix. So here's a linear system. We're going to have the three equations: 2x minus 7y plus z equals negative 25, x plus 5y minus 8z equals 81, and negative x plus 4y plus 3z equals negative 18. The augmented matrix is going to just be a matrix where the first row takes the coefficients and the constants of that first equation. So we are going to write 2, negative 7, 1, negative 25. The second row just takes all of that from the second equation. 1, 5, negative 8, 81. And then the last row takes the coefficients and constants from the last equation. Negative 1, 4, 3, and negative 18. And that's our augmented matrix. Now we also need to talk about a particular form. We're calling it row echelon form. We say that a system is in row echelon form also sometimes called triangular form, when the last equation contains just one variable and each equation above contains the variables below and an additional variable. And the leading coefficient of each equation is going to just be 1. So, I'm going to give you now a linear system that is going to be in row echelon form, and then we're going to write the augmented matrix version of that. So here's our linear system. Our first equation is x minus 2y plus 5z equals negative 29. The second equation is y minus 6z equals 26, and the last equation is z equals negative 3. The augmented matrix form of that is going to simply be 1, negative 2, 5, negative 29, and then 0, 1, negative 6, 26, and 0, 0, 1, negative 3. Row echelon form is very nice because we can just use back substitution. We can take that last row and substitute it in to the one previous to that, and then find the next variable, and then take those values and substitute them in to the one, the beginning one. So now, before we get into any examples, I want to go over some elementary row operations. So all elementary row operations is they can produce equivalent systems and can be applied to an augmented matrix to transform it to row echelon form. And those operations are to interchange any two rows. We can do that. We can multiply a row by a non-zero constant. We can also add a multiple of one row to another. So now let's talk about the process of Gaussian elimination. First, a little history lesson. Gauss, Carl Friedrich Gauss, is a German mathematician which this method is named after. There are some steps, the first of which is to write the system as an augmented matrix. Then we're going to transform the matrix into row echelon form using our elementary row operations. Then we're going to use the row echelon form of the augmented matrix to rewrite the system of equations. And lastly, we are going to use back substitution to solve for the variables. So now we're going to get into some examples. So our first example is going to be the system x plus 2y minus 9z equals negative 59, y plus 4z equals 12, and x minus y plus 3z equals 25. So first, we're going to write this as an augmented matrix. So we're going to have 1, 2, negative 9, negative 59. We're going to have 0, 1, 4, 12, and then 1, negative 1, 3, 25. So now I'm going to use some row operations. Now, with the row operations I'm going to use, I want to make this last row, well, in fact, I need to get rid of the first and the second 1, and then I need to make this 3 into a 1. So first, let's just focus on getting rid of that first 1. What I'm going to do is I'm going to take the third row, R3, and I'm going to subtract the first row from it. And that's going to give me a new third row. So first, I'm just going to write my third row. 1, -1, 3, 25. And then I'm going to write my first row. 1, 2, -9, -59. And I'm going to subtract the entire first row from the third row. What that does is that first 1 is gone. -1 minus 2 is -3. 3 minus -9 is 12. And 25 minus -59 is 84. So now what I'm going to do is I'm going to rewrite my matrix. I'm going to leave the first 2 rows as they were. So 1, 2, -9, -59, 0, 1, 4, and 12. But now I'm going to replace that third row with what we just got, really in step 2. So 0, -3, 12, and 84. Okay, so now I'm not quite there yet. I still need to get rid of this first number in that third row and make that second one. In fact, it's the second number I need to get rid of, and the third one needs to be converted into a 1. So what I'm going to do is I'm going to take my third row, I'm going to add to it 3 times my second row, and then I'm going to replace my third row with that result. So I'm going to have 0, -3, 12, 84, and then I'm going to have 0 times 3 is 0, 3 times 1 is 3, 4 times 3 is 12, and 84 times 3 is 100. Correction, 252. And I'm going to add those. And I actually made a mistake. I did not want to multiply 84 by 3. I want to multiply 12 by 3, which is 36. Now I can add those rows. 0 and 0 is still 0. -3 plus 3 is 0. 12 plus 12 is 24. And 84 plus 36 is 120. So we've got a new matrix. Keeping our first 2 rows, 1, 2, -9, -59, 0, 1, 4, and 12. And now we've got 0, 0, 24, 120. So what we need to do now, our final step, is take that 24 and make it 1. So all I'm going to do is I'm going to take R3 and I'm going to divide it by 24 to get a new R3. Now instead of writing it all out, I'm just going to rewrite the matrix. So we have our first 2 rows, 1, 2, -9, -59, 0, 1, 4, and 12, 0, 0, and then 24 divided by 24 is 1, and 120 divided by 24 is 5. So we're almost there. What we know, in fact, I'm going to rewrite this as a system. So now as a system, this now looks like x plus 2y minus 9 equals -59. Y, in fact, I forgot to put something with that -9. That -9 should be multiplied by z, then equals -59. And then our second equation is y plus 4z is equal to 12, and then our last equation is z equals 5. So we know for our solution, at least the z term is 5. We can now use back substitution to take this 5, put it in for z. Y plus 4 times 5 is equal to 12. 4 times 5 is 20. So y plus 20 is equal to 12. If we subtract 20, we get y is equal to negative 8. So let's put that in our solution. Now we can take both our z and we can take our y we just found and plug them both into the first equation. Get an x plus 2 times negative 8 minus 9 times 5 equals negative 59. Well, 2 times negative 8 is 16, negative 16 even, so we've got x minus 16. Negative 9 times 5 is minus 45 equals negative 59. Negative 16 minus 45 is going to give us x minus 61 equals negative 59. When we add 61, we're going to get x equals 2. So we found our solution to the system. It's 2, negative 8, 5. Let's look at another example. So example 2, I'm going to have the system x minus y plus 4z equals 6, and x plus y minus 2z equals negative 14. And lastly, x plus 2y plus 5z equals 6. So first I'm going to write this as an augmented matrix. So I'm going to have 1, negative 1, 4, 6, 1, 1, negative 2, negative 14, and 1, 2, 5, 6. So I'm going to actually focus first on getting that third row the way I want it. So I'm going to start by going R3, the third row, and subtracting the first row from it, and then get my new third row. So I'm going to go 1, 2, 5, 6, minus 1, negative 1, 4, and 6. So I'm going to end up with a 0, a 3, 1, 0, which means my matrix now looks like 1, negative 1, 4, 6, 1, 1, negative 2, negative 14, and then 0, 3, 1, 0. And really, before I can continue finishing that row, I'm going to also eliminate that first term in the second row. So I'm going to go R2 minus R1 to get my new second row. So I'm going to go 1, 1, negative 2, negative 14, minus 1, negative 1, 4, 6. So I'm going to have 0, 2, negative 6, and negative 20. So my new matrix is going to look like 1, negative 1, 4, 6, 0, 2, negative 6, negative 20, and 0, 3, 1, 0. While I'm at it, I'm just going to take R2 and divide it by 2 to get my new second row. So my new matrix is going to be 1, negative 1, 4, 6, 0, 1, negative 3, negative 10, and then I've got 0, 3, 1, 0, which now I just have to finish that third row. And to do that, I'm just going to go and take my third row minus 3 times my second row to give me a new third row. And we're actually running low on time, so I'm going to finish this example in our next video.